In the previous lecture, we had discussion on number systems with different bases. And now, in this presentation, we are going to understand how addition is performed in number systems. We will understand how two numbers are added in a given number system. And while doing so, we will also understand the significance of place values in generating the carry. So let us move on to our first addition. 672 in decimal when added to 29 in decimal gives us what in decimal? So we have two numbers and we want to add these two numbers. Both of them are in decimal number system and the result of addition is also in decimal number system. So let us understand the complete mechanism of addition in decimal number system. We have taken the example of decimal number system because we all are aware of addition in decimal number system. But most of us are still confused in the carry generation part. And with the help of this example, we will try to make it clear for everyone. Alright, so our first number is 672, 672. Our second number is 29, 29. Now why I have written 9 below 2 and 2 below 7? There is a reason behind it. We want to write down the digits of the two numbers according to their place values or the index. Now what is this place value and the index of the digits? We'll first talk about the index. If I take this number 672 and if I assign 0 to 2 as its index, and if I move in this direction from right to left, 7 will have the index 1, 6 will have the index 2. So 0 will be the index of 2, 1 will be the index of 7, and 2 will be the index of 6. So we are starting with 0 and we are adding 1 every time moving from right to left. Similarly, 9 will have index 0, 2 will have index 1. So 2 and 9 are placed in the same column because they have the same index. 7 and 2, they are placed in the same column because they have index 1. 6 is placed in this column because it has index 2. And the second number doesn't have a third digit, therefore we have left this spot empty. So I hope the placements of the digits of the two numbers is now clear to you. 0, 1 and 2, they are the index of the digits in the numbers. And now we will understand what do we mean by the place value of a digit. The place value of a digit is equal to the base of the number system the digit of the number belongs to the power index of the digit. For example, let's take digit 2 of this number. We know 672 is a decimal number and therefore the base is equal to 10. So 2 will have the base equal to 10 and 2 is having the index equal to 0. So following this, we will have 10 raised to power 0 where 10 is the base and 0 is the index. So in this way, we are getting the place value of 2 equal to 10 raised to power 0 and the same place value will be there for this digit 9. 10 raised to power 0 is equal to 1 which is unity and therefore we say digit 2 and digit 9 are at unit place. Similarly, when we calculate the place value for digit 7, we will have the base equal to 10 and the index equal to 1. So we will have 10 raised to power 1 which is equal to 10 as the place value for 7 and also for 2. And hence 7 and 2 are the digits at 10's place. 6 will have the place value equal to 10 raised to power 2. 10 is the base and 2 is the index. 10 raised to power 2 is equal to 100 and therefore 6 is at 100's place. So in this way we can find out the place values of digits in a given number. Now the next thing is to understand how these digits are contributing to the formation of the number. The contribution of the digit depends on the digit itself and also its place value. We need to multiply the digit by its place value to get the contribution by the digit. For example, the contribution of 2 will be 2 multiplied to 10 raised to power 0, which is equal to 2. 10 raised to power 0 is equal to 1. 1 multiplied to 2 will give us 2. And the contribution by digit 7 will be 7 multiplied to 10 raised to power 1, and this will give us 70. Similarly, we will find out the contribution by digit 6. It will be 6 multiplied to 10 raised to power 2, which will give us 600. Now, all these contributions by different digits will be added. 600 plus 70 plus 2 will be equal to 672. Following the same way, we will have 20 plus 9 equal to 29 for the second number. So I hope now you understand the basics of number formation as well, and it is time to move forward and perform the addition of these two numbers. The step 1 is to add the digits of the two numbers having the same place value. For 10 raised to power 0, that is 1, we will add 2 and 9. 2 plus 9 is equal to 11. And this 11 is the contribution in the final number when we add 2 and 9, the digits at the ones place. And now we want to get our carry and the intermediate sum. The carry will be transferred to the next column and the intermediate sum will be kept in this column. So now we will understand the process of carry generation and how we are getting the intermediate sum. This 11 we can write as 10 plus 1. So we will break 11 and we will write it as 10 plus 1. Now we have something like this, 70 plus 2. Here we have 10 plus 1. Now in the next step, I want to write the digits along with their place values in this. So we will have 10 written as 1 multiplied to 10 raised to power 1. And we will have 1 written as 1 multiplied to 10 raised to power 0. Now when you observe properly, you will find we have two digits, 1 and 1. This 1 has the place value equal to 10 raised to power 0, which is the place value of this column. So this 1 can remain in this column, but this one is having the place value equal to 10 raised to power 1, and 10 raised to power 1 is the place value of this column. So this one cannot remain in this column, it has to go to this column. So we are going to have this one, which is our intermediate sum, in this column, and we are going to transfer this one to this column. And this one here is what we call as the carry generated. So when you add 2 and 9, you will have 1 here and 1 will be the carry. So I hope you got the idea why we have carry generated when we perform the addition. And following the same process, we are going to add the digits we have at 10 raised to power 1's place. We have 7, 2 and we have 1 along with them. 7 and 2 are the digits of the two numbers and 1 is the carry generated from the previous addition. So we have 1 plus 7 plus 2 giving us 10. Now this time the result 10 when multiplied to the place value 10 will give us 100, and in the previous case the result 11 when multiplied to the place value 1 gave us 11 only. So here we will have 100. 100 we can write as 1 multiplied to 10 raised to power 2 plus 0 multiplied to 10 raised to power 1. So we will have 1 multiplied to 10 raised to power 2 plus 0 multiplied to 10 raised to power 1. Now when you observe these two digits, you will find 0 is having the place value 10 raised to power 1, which is the place value of this column. So this 0, the intermediate sum, will remain in this column. Now talking about this 1 here, it has the place value equal to 10 raised to power 2, which is the place value of this column. So this 1 here is our carry generated, and we will move it to this column. Now we will move on to perform the addition in our final column, that is the column having the place value 10 raised to power 2. In this column, we have 6 from the first number, we have no digit from the second number, and we have 1 as the carry from this addition. So we will add 1 and 6 and we will get 7. Now this 7, when multiplied to the place value 100, will give us 700. 700 we can write as 7 multiplied to 10 raised to power 2. So we have only one digit, and the place value of this digit is 10 raised to power 2, which is the place value of this column. So there will be no carry generated, and this 7 will be our final digit of the result. So the answer is 701 when we add these two decimal numbers. We will get 701 in decimal after adding 672 and 29 in decimal. So in this way we are done understanding the details of addition in decimal number system, and now we are going to note down some observations which we are going to directly use in the additions of other number systems. Focus on this result we have obtained after adding 2 and 9. 11 gave us sum as 1 and carry as 1. And when you compare 11 with the base of the number system in which we are performing the addition, you will find 11 is greater than 10. So when the obtained result after adding the two digits is greater than the base, a carry will be generated. And what about the intermediate sum? How to find it? To find it, you simply need to subtract the base from the result of addition. So we will subtract 10 from 11 and this will give us 1. 11 minus 10 is equal to 1. So 1 is intermediate sum, and as the result of addition is greater than the base of the number system, carry 1 will be generated. Let us now focus on this result. 10 gave us 0 as the intermediate sum and 1 as the carry. When you compare 10 with the base of the number system, you will find 10 is equal to 10. So we can see that when the result of addition is equal to the base, then also the carry is generated, and the intermediate sum will be equal to 10 minus 10, giving us 0. And the final case is when the result is less than the base of the number system. No carry is generated in this scenario, and the intermediate sum is equal to this result itself. And now when you observe properly, you will find we are performing the division in all the three cases to get our intermediate sums and the carries. We are performing the division by base, which is 10, and we are noting down the quotient along with the remainder. The quotient will be the carry and the remainder will be the intermediate sum. To make it clear, I will take this case once again. We are having 2 and 9 as the two digits we want to add. When we add 2 and 9, we will have 11 as the result. So 11 is the contribution by 2 plus 9, And to find out the carry and the intermediate sum, we will divide 11 by the base, which is 10. 11 when divided by 10 will give us quotient equal to 1, and the remainder will also be equal to 1. And the quotient is our carry and the remainder is our intermediate sum. And this method is called as division by base method. And now we will quickly verify these two cases following the division by base method. In tens place, we are adding 1, 7 and 2. 1 plus 7 plus 2 is giving us 10. 10 when divided by the base, which is 10, will give us the quotient equal to 1, which is our carry, and it will give us the remainder equal to 0, which is our intermediate sum. Moving on to hundreds place, we have 1 plus 6 giving us 7. 7 when divided by the base 10 will give us the quotient equal to 0, and therefore the carry in this case is equal to 0, and we will have the remainder equal to 7, and therefore the intermediate sum is equal to 7. So in this way we can see that we are getting the same result following the division by base method. And therefore, from now on, we will be using division by base method to perform the addition of two or more numbers in other number systems as well. So in this way, we are done with our first addition, in which we performed the addition of two decimal numbers, giving us a decimal number. And I hope you now understand how carry is generated and how we can have the final sum by the help of intermediate sums. So now we will move on to our second addition. In this case, we want to add 1011 in binary with 110 in binary, and we want to note down the result in binary as well. And we very well know that in case of binary number system, the base is equal to 2. And as per the question, our first number is 1011, our second number is 110, and you can see that I have placed the binary digits according to their place values. 10 has the place value 2 power 0, which is 1. 11 has the place value 2 power 1. 01 has the place value 2 power 2, and 1 has the place value 2 power 3. And this time, we will not go and do the tedious calculations keeping in mind these place values. We will simply be using the divide by base method to find the final answer. So let us start now. 1 plus 0 is equal to 1. 1 when divided by the base 2 will give us the quotient, which is the carry, equal to 0. And it will give the remainder, which is the intermediate sum, equal to 1. Let's move on and add these three. 0 plus 1 is equal to 2. 2 when divided by the base 2 will give us the quotient or the carry equal to 1, and the remainder will be equal to 0. So we will have the intermediate sum equal to 0. Moving forward, we will add 1, 0 and 1, giving us 2 again. 2 when divided by 2 will give us quotient or carry equal to 1, and the remainder or the intermediate sum will be 0. And at last we have 1 plus 1 giving us 2. 2 when divided by 2 will give us carry equal to 1, and it will give us the intermediate sum equal to 0. This means we have 1 plus 0 giving us 1. So in this way we have 10001 in binary as the result of this addition. We have 10001 in binary as our answer. And I hope you now understand how to use divide by base method when we have binary addition. Let's move on to our third addition. We have 172 in octal and we want to add 67 in octal to it, and then we want to note down the result of addition in octal. We all know the base in case of octal number system is equal to 8, and as per the question, our first octal number is 172 and the second octal number is 67. I have properly positioned the digits of the two octal numbers, and now we can start the addition. 2 plus 7 is equal to 9. 9 when divided by 8 will give us the quotient or carry equal to 1, and the remainder or the intermediate sum will be equal to 1. 1 plus 7 plus 6 is equal to 14. 14 when divided by 8 will give us the carry equal to 1, and it will give us the intermediate sum equal to 6. 1 plus 1 is equal to 2. 2 when divided by 8 will give us carry equal to 0, and the intermediate sum, that is the remainder, will be 2. So in this way we have 261 in octal as the answer. So we have got 261 in octal as our answer. So I hope all the concepts explained in this presentation is clear to you. In the next presentation, we are going to perform the subtraction in different number systems. So I will end this lecture here. See you in the next one.